daily sleep requirements. Yes, this is strange, but I'm living proof. When you're younger, you need 8 hours to sleep. I'm old and decrepit, I get along with 4 or 5. I mean, I can't stay asleep longer than that. I just get up at 4 or 5 in the morning, depending on when I went to bed, it's like, oh well, time to start my day. My wife says, don't you touch me. I'm going to sleep until, 7 o'clock. But no, 4 or 5 hours is maximum. I can't do it any longer than that. Okay, so remember, the only thing we need to understand for the test, REM sleep is where you are your deepest sleep and your eyes are moving, rapid eye motion, and your body is pretty much paralyzed. Okay? And when you are in non-REM sleep, which happens in between REM sleep, that's when you don't move your eyes, but you can move your body around. 10-4? And we go in cycles. Got it? We do cycles throughout the night. The most important one is the REM sleep, because if you don't get enough of that, you're in a foul mood the rest of the day. Alrighty? And it is believed to be when we are reliving the most important part of that day. Okay? So, keep that in mind. Alright, some of the disorders that might be a wrong or a right answer on a test. Narcolepsy. This is, you're just walking all the way, boom, you just fall asleep. Got it? There was a little video on YouTube, you can see it. This little dog has a narcolepsy problem. A little foo-foo dog, it runs around the yard, boom, falls over. It wakes back up, runs, then falls over again, asleep. Okay? That's narcolepsy. Insomnia, can't sleep. Sleep apnea. Now, what is this? What is A in front of any word in science? Not. And this, apnea, or nia with the P silent, is breathing. Not breathing in the middle of your sleep. That's a person who's like, has a big inhalation of nasty sounding snoring. It's because their brain is saying, wait a minute, I'm running out of oxygen here. I'm building up too much carbon dioxide from not breathing. And that will obviously affect your sleep at night. You may not be conscious of it, but you are interrupting your sleep cycle, and that's why you feel tired the next day. And of course, your partner is going like, what's this freight train coming through the, And for a lot of those people, a CPAP machine really comes in handy for them. Gets them to sleep, they got better attitude the next day because they're getting their 8 hours, that kind of stuff. Okay. All right, language. Where is language spoken? Where do we form words like I'm forming right now? What's that called? Broca's region. Where is it located? On the left side. Where is the part that you can hear me and understand what I'm saying? What's that called? Wernicke's region. And where is that? Right here. Got it? Now, was Broca and Wernicke on this last lab practical? No? It's going to be on the next one. Got it? Because that's what this is. We're getting ready for the lab practical and the last test. Got it? Lab 4, test 4 is what's coming up. Okay, so be careful. And only in about, corresponding are nonverbal components, but we have found, through trial and error, that about 10% of the human population has their Broca's and Wernicke's on the right side. And the only reason we know that is because some kind of head trauma, some kind of stroke, and they can still speak. So they must be one of the ones with it on the other side, okay? Because you can't see this. It's not an organ. Got it? It's an area of the brain. Hence the ... Got it? It's an area. All right, memory. We started talking about this as the last thing before we left. Short-term memory versus long-term memory. Which of the two is best for us to take to a test?
Long-term.
Exactly. Because this is temporary. This is that reverberating or circular thinking. Keep it in your mind, keep it in your mind, keep it in your mind. Got it? And they can only hold 7, 8, maybe 10 pieces of information. Well, unless you have a test that's only 5 questions long, this is not a good plan. Okay? You want the long term. And what helps us with long term is our emotional state. Remember, if your hippocampus is calm, you can learn. Got it? If your reticular activating system is busy helping you, either by focusing your attention or by pushing the extraneous noise out of the way so you can focus, that's why you need to know. Do you need quiet or do you need a fairly noisy? I don't mean like, try to study in the middle of a train station or a ballpark, but, do you need a little bit of background noise like the radio on or something? Okay, radio, sorry. I don't mean to be dating myself for how old I am, but having music in the background. All right. Rehearsal. In other words, are you only going to look at this stuff once? You need to know by now, how many times do I need to hear it or see it or say it out loud or whatever in order to get 100%. Most of my students who are successful tell me 3 times is what they need. Okay? So, if you find yourself, I've looked at this 12 times and I can't get it, then you're doing it the wrong way for you. Does that make sense? That's all there is to it. Don't make it any harder than that. Your brain will tell you what's working and what's not working. It's trial and error sometimes, but I'd rather you figure it out before we move on. Because 211 is going to be tougher, and nursing school, if that's your goal, is going to be even tougher. So it's best if you already have your modus operandi figured out. Got it? Your method of study is figured out. Okay, association. Folks, this is why I tell you stories. This is why I look around and see if I can pick up pieces of paper or pencil or whatever and imitate stuff. Got it? That's association. Can you hang this new material on something that you can physically see or a story you can remember? Alrighty? That's association. Now here's the thing. Do you realize all of us have automatic memory? Everything you've ever heard, read, seen, felt, tasted is actually in your brain. The problem is access to it. Got it? Some people can just, boom, like the Sheldon Cooper character on
Big Bang Theory.
Yeah, Big Bang Theory. Okay? He's got one of these, mnemonic memories. Alrighty? I sure don't. Okay? I gotta, dig to try to find it. But I know it exists because when my mom was going through Alzheimer's, we realized something was wrong when she would say, oh, how are the kids doing? We said, oh, well, Michael's doing this and Steph's doing that, Virginia's doing that. Oh, that's good. So how are the kids? She couldn't hold any new memories, but at least she understood that we had kids. Later on, she, didn't realize that she was married to Pop, who had passed away. So thank goodness, because I hated when my brother-in-law said, well, Pop died last year. Oh, no, But later on, we just said, oh, Pop's just outside or doing something. Then later on, she forgot. Then later on, she forgot she was married and was asking where her mom and dad are. And I remember up until the last year, she was asking me, well, where's Yanni? And I'm going, Mom, who's that? He goes, the little boy that lives next door. Because she was going back to her childhood. Okay? And she didn't know who we were. We were taking care of Mom. And, she's going, I'm just a nice person here, But she could remember things from her past because it's all locked up. It's just that this cruel disease was slicing away year after year. Got it? Until all she had left. That's why her last year, she was speaking Dutch and Indonesian the whole time. Because that's where she grew up in. A Dutch colony in Indonesia. So thank goodness I know some Dutch, so I was able to converse with her. And my sister and my brother when we were there. But not my spouse and not my sister's husband, going, what is she saying, We have to translate it for them, okay? But everything is in there. And that's why we had that one part of the brain that said, remember, parallel learning. That's why you smell apple pie and it reminds you of your grandmother's apple pie, even though that might have been 30 years ago for somebody like me, 40 years ago, because everything we've ever experienced is in there. The trouble is we can't access it, okay? Now my dad could. I remember when I made some bad grades in high school, he goes, what's wrong with you? Didn't you read your textbook? Yeah, I did. He said, well, can't you just read that in your mind when you're taking the test? I went, no. He goes, I can. Well, thank you, Probably why you were a boy genius, I must have been dropped on my head or something. But my dad said, oh yeah, it's very simple. If I'd read the textbook, any question on the test, I could actually go through the pages in my mind and read that out of the textbook. He said, can't you? No, I've never been able to do that. Holy cow. All right. Declarative memory is what we do in this class. It's fact-based memory. Do you know what this is called? Howdy. Do you know what that is called? Right? Do you know how this works? All right. Non-declarative is basically skill memory. Okay? Like how do you drive a car? How do you do roller skating? That kind of stuff. It's more of a motor memory. 10-4? Like a lot of these folks who, I guess they dance, like Dancing with the Stars or whatever. They say it's muscle memory. You do it so many times, you know exactly. You do this turn, then you do that. I can't keep track of that stuff. I fall tripping up and down the stairs. Okay? So, does that make sense? But the cool thing about this kind of motor memory is that once you've learned it, it's hard to unlearn. You see, if you are kinesthetic, as I am, the more I teach it, it's almost like a motor memory. I can't unlearn this material. I have gone over it in a teaching method, in a kinesthetic method, so many times. Okay? And one of the things they're going to try to teach you in nursing school is that they want it to be like a motor memory, a muscle memory. What do you do if your patient codes in front of you? It can't be, well, let me look that up. It's like, boom, you do this, then this, then this, because you've practiced it over and over and over again. Does that make sense? They want you to be able to just jump into action. Folks, that's the same thing, that firefighters, you don't want them to go, gee, there's a fire, I wonder what I should do. They practiced what to do. How about the Secret Service agent that jumped all over Donald Trump during the shooting this weekend? You are aware that happened, right? Yeah. That's all muscle memory. You jump on top of the person whose job it is you're supposed to protect. So, all right. 2 kinds of amnesia. And I put these movie posters here because my students keep saying, oh, you mean like that movie? You mean like that movie? So I said, okay, let me just put the poster up here. Anterograde amnesia. Remember, anti, forward, retro, backward. Are you familiar with those 2 terms, right? Anybody ever heard of playing poker? Okay. What does it mean to ante up?
Put in whatever.
You put in your first bid. You put in your first dollar or whatever. Got it? To be able to play in the game. Then you get your cards. Does that make sense? Then once you get your cards, you can start bidding. I'm going to put in an extra $10 or I think I got a good hand. That kind of stuff. But ante means first, forward. So, in this movie, 50 First Dates, she couldn't remember anything that was happening right at the moment. That's why he had 50 chances to figure out what she liked and what she didn't like so he could be the perfect date. 10-4? But, it's like What's today? I don't know. It's Tuesday. Okay, what's today? I don't know. Couldn't keep the memory. Got it? Okay. If you've watched the Bourne Identity series, a little bit different than the books. I read the books first. He's got retrograde amnesia. He can't tell what he did in the past. He has no idea that he is a secret agent. Got it? Because he got shot, and it messed up his memory. 10-4, no memory forward, no memory from the past. Got it? Okay. All right, let's protect our brain, shall we? We protect our brain with bone, with 3 connective tissues called the meninges, with a watery cushion. Yes, your brain floats inside your skull. And the astrocytes, remember, protect your brain from getting what? Urea.
Yes.
Okay? We don't want the urea to go into our brain because that will destroy our brain. Okay, so 3 meninges. Mater is Greek for mother. This is the durable or tough mother. What's arachnophobia?
Scared.
Spider. This is the spider mother. And this is the gentle mother. Okay? So let's explain what's going on. The outer layer is the tough one. That's the dura mater. Very tough, almost like a layer of plastic. Okay? And under the dura mater is the subdural space. Does that make sense? The space under the dura, sub. Where's a submarine go? Under the sea. Marine is sea, right? Marine life. We're not talking about things in a tree, right? Okay. So underneath the dura mater, in the subdural space, is what we call the dural sinus. It's a large blood vessel that receives all the venous blood, all the deoxygenated blue blood that your brain has finished using. Below that is the arachnoid mater. Arachnoid means spider. Well, here it's because when you look through it, you see a spider web of capillaries. Got it? So in that subarachnoid space are all the capillaries on the surface of your brain. Got it? And the spider web gives it the spider mother name. Alrighty? And so underneath that in the subarachnoid space are where you have your blood vessels. Then below that is the pia mater, the gentle mother. It is a thin little layer that is directly glued to the surface of your brain. Okay? And when we dissect, let's try to dissect next week. Okay? Because I got to get through this in the eye, and then we're going to dissect the eye and the brain. Good job? You'll be able to take a pair of tweezers and peel that pia mater off of the brain. You'll be able to see it's very thin. And if, depending on how they cut the brains for us, you'll be able to see that tough dura mater as well.
What type of brains are eyes?
These are fetal pig brains or sheep brains, sort of sheep. Sheep brains and I think cow eyes. Okay? When we get to 211, we're going to dissect the pig heart. But this is a heart like this big, because these are like 400-pound pigs, the ones that you turn into bacon and stuff. All right. See? The dura mater covers the entire brain, and right underneath it is the dural sinus, collecting the venous blood from your brain. All righty. So, what do you think you need to know on test number 4? From the outside to the inside, plus the spaces underneath. So it's very simple. Dura mater, arachnoid mater, pia mater. Got it? Subdural space. Gee, where would that be? Under the dura. Subarachnoid. Where would that be? Under the arachnoid. Is there a sub-pia space? No, because it's directly on the brain. Don't make it hard. It's right there. Okay, CSF. This is your cerebrospinal fluid. What is it? It's almost like your blood plasma, the liquid part of your blood minus the red and white blood cells. Okay? But a slightly different ion concentrations, different concentrations of, of your hydrogen ions and your bicarbonate ions and your sodium ions. Okay. What's its function? This is the liquid that your brain floats in. Number 2, because it is covered, when you get hit in the head, that watery layer slows the brain down before it hits the side of your skull. So it helps to protect you against concussions and stuff under regular circumstances. Got it? And it nourishes the brain and feeds it vital chemical information. Okay? And there you go. Here's your brain. And remember, your cerebrospinal fluid is made in your ventricles. Oh, I'm sorry, I got one up there. Remember the ventricles? Let's make sure we name them. The 2 lateral ventricles on the side come together to the 3rd ventricle, which is shaped like a chicken with a beak. Got it? Because the chicken head is where the thalamus would be, and the chicken beak is where the hypothalamus would be. Got it? Because remember, this is in the middle. You got 2 thalami with the 3rd ventricle in the middle. Got it? And 2 chicken beaks down here, 2 hypothalami with the liquid in the middle. Then you got this cerebral aqueduct going to the 4th ventricle. Do you see the pink? Hold on. I'll pass this around for you guys. Do you see the pink underneath and the pink on top? Guess what the pink represents? That's the capillaries that leak their plasma into these chambers. 10-4? Pass that around. Okay? That's what these blood vessels are. They are the ones that leak the liquid in to make your CSF. Alrighty? And we call those areas what? Choroid plexus. What's a plexus? Is that one thing or a complex of things? It's a complex. It's a bunch of capillaries. Got it? It's not one, it's a bunch of capillaries. And the word choroid means blood vessels. Okay? When we look at the eye in chapter 16, there's an area of the eye full of blood vessels, and guess what that area is called? The choroid. The retina is where the nerves are, and behind that is where the blood vessels are. The choroid. Does that make sense? Okay. All right. So, we have these in the lateral ventricles. We have one on the top of the 3rd ventricle, the chicken head with the beak. And we have one on top of the 4th ventricle. And that fluid flows down the center of your spinal cord, then comes back up on the outside of your spinal cord, and goes around your brain and ends up in that dural sinus. Because what goes in must come out. Does that make sense? Because if everything came into your brain and stayed there, our brain would be this big. But it wouldn't be very helpful because it would be full of water. Can you? I just want to make sure for the video that we look at underneath. Am I there?
Yep.
Okay. He put up last week's videos for you to look at. Okay? So the cranial nerves and 14 are up. All right? This is the second half of 14. So, see the pink here and the pink here? That's the choroid plexus for each of the 4 ventricles. Okay? All right, super. Excellent. Okay. besides your brain. See, does your brain touch this part of your skull? Is it touching this part of your skull? Is it touching this part of your skull? Why is the brain floating? Okay, here's the reason why. There's something else floating and never touching the sides while it is growing inside you, ladies.
Baby?
Babies. Aren't they floating around in a bag called the amniotic sac? Floating in liquid called the amnion? Oh, just off the top of your head, what is the amniotic fluid made out of? Like this. It comes from mom's blood. Got it? The plasma part of it? What is it in the last month or two of the 9 months you're floating in that bag, y'all? Urine. You're floating in your own pee-pee. I mean, you got to make sure those organs are working, and we got no bathroom, there ain't no porta potty in there. So you're actually floating on your own pee-pee. Is pee-pee acidic or basic?
Acidic.
Is it a good idea to have acid on your skin all day long?
No.
So what do we have on our skin as a baby to protect us against the acid? That was on test number 2. What's it called? Vernix caseosa. Okay? A cheesy substance made by who? The sebaceous glands, the oil glands. Because oil and water don't mix. Your pee-pee is mostly water, and the oil will keep the water from touching and therefore damaging your skin. 10-4. And it's also nice and slippery, so whoop, out comes the baby when it's birthday time. 10-4? Okay. So, we don't want the baby to be head down in your pelvis. Just like we don't want our brain to be smacked down on the bottom of our skull. And that's because what happens to a little old lady who is not turned correctly while in the nursing home?
Bed sores.
You get a bed sore. It's called a decubitus ulcer. Because gravity is crushing their skin between their pelvis bone and the mattress. 10-4? And that's why, where do they have most of their ulcers? Here. I mean, feel it right, feel it your own. Is there a lot of muscle and stuff between your finger and that bone? No. So it's very easily crushed by gravity. 10-4? Think about it. When you're sitting in your chair, you're not sitting on your sacrum. You're sitting on your gluteus, right? That's a muscle. There's less chance of having a decubitus ulcer. Does that make sense? So, we don't want the baby's butt to be crushed, or the baby's head if it's facing down. Just you don't want this part. You don't want this part of your brain to be crushed, this part of your brain to be crushed, this part of your brain to be crushed. So we make sure that both the brain and the baby are floating 24/7. 10-4? Okay. And that's all there is to it. Speaking of that, look at this. Blockage of what structure could have caused this? This is called hydrocephaly. Water on the brain. What happened? Why is this kid's brain so big? It's not his brain that's big. His brain is full of what? Water. So what got blocked? This is making water, and it goes down. So what got blocked? The aqueduct. The cerebral aqueduct. It's blocked. So we make more water and more water and more water. Well, guess what? It can't go down, so it's going to go like this and crush that baby's brain up against its skull. That's permanent brain damage for this poor kid. Okay? And that's why, prenatal care is so important because they can see this might be happening to your baby while it's still in the womb, still in the uterus, and they can actually do microsurgery now and put a stent in there. Okay? Stick a stent in here to open this up to start draining that out and reduce the amount of damage. Not have to wait until the baby is born and put a stent in from the outside. Okay? Because the damage has already been done. His brain's already been crushed up against his skull. Does that make sense? You had a question, Mike?
So the brain, or so when the baby's born like that and his head is already damaged, how do they get the, like I know you said the stump, but do they do it like all at one time, or do they do it?
Oh, if I could do it as soon as possible, I can't imagine them waiting much longer. But like I said,
all,
now they can do it in the uterus if they see it already happening.
all the fluid at one time?
They try to drain it as much as they can. I mean, they can't suck it out, you know, like with a vacuum cleaner, but they do allow it to drain out, so there's not more being saved than being made. Does that make sense?
What could be like the effects of the baby if that happens?
Permanent brain damage, so they won't be able to do much. Depending on how much damage there is, it's going to be very hard for them to talk and walk and do that kind of stuff. Yeah, so the earlier we can detect it and take care of it, the better off. Does that make sense? Yeah. So, cool little thing. All right. So, we're producing this at a constant rate. All right. Who's moving that fluid up and down? Remember, there's ependymal cells with what on their surface?
Cilia.
Cilia. That's right. There they are. Okay. They're right here below those choroid plexus. So that makes the fluid, and that pushes it around inside that hollow space called the ventricle. All right, we got the blood-brain barrier to keep the urea out. Very good. Made by who? The astrocytes. See how a lot of this stuff keeps coming back? Yeah. There you go. All righty. Of course, it's absent in the vomit center, also known as the emetic center, because emesis means to throw up. All right. How about some problems? Again, maybe one question. So one right answer, 3 wrong answers. Does it make sense? Just keep an idea. Concussion, temporary knockout, but then you're back to what I think is normal. All right. A contusion, that's an actual bruising of the brain. So that's more of a permanent thing. Subdural or subarachnoid hemorrhage, that is very bad because if the subdura with this blood starts to form, is your skull going to move out of the way? So it's going to crush down on your brain. Got it? That's the problem with bleeding in the brain, is that the blood is going to keep coming and it's going to crush the living nerve tissue in your brain. Alrighty? When we have that here, we get swelling. But you can't swell your skull out of the way. Okay? Alright. Cerebral edema, again, very, very dangerous. That's your brain cells themselves swelling up because of damage. Okay? In fact, the only way to help somebody with this is you have to let your brain swell and then go down. How can you let your brain swell when your skull is in the way? You take your skull out of the way. Okay? This happened many moons ago in Las Vegas. There was a show called Siegfried and Roy, and these 2 guys were magicians, but they also had a bunch of big tigers and stuff. And in one episode, one of the tigers got spooked by something and knocked down either Siegfried or Roy, I can't remember, and wanted to pull him off of the stage, bit him in the head and pulled him off the stage. Got it? Well, that caused traumatic brain injury, and when he was in the hospital, the doctor said, oh my gosh, this guy's brain is swelling so fast, we've got to do something. So the only thing they could think of is that they cut his skull out of the way and let the guy's brain swell out and until it was back to normal. Then they could put the skull back in. Well, what did they do with that living piece of skull bone? You leave it sitting out there, it's going to dry up and die. So what do? They opened his abdominal cavity, put that inside, and closed it up. And the abdominal fluid kept the brain cells alive until the swelling went down. Then they could put that back on. Okay? So that's some of the things they do now for a person who's got a swelling brain. Got it? Because if the brain swells and you got a skull here, crush, permanent damage. All right? All right. How about this? A CVA, a cerebral vascular accident. Well, what is this? There's something wrong with the blood vessels. Either those blood vessels are blocked, and therefore I can't get blood to this part of my brain, or the blood vessels have popped, and I'm losing blood, and I can't get blood to this part of my brain. Got it? And, it's called a stroke. Got it? And so we need to do something for that patient. Does that make sense? Because, again, if I don't get oxygen to this part of my brain will die. 10-4? So we call that a CVA. What's a TIA? That's a transient ischemic attack. So let's look at these words. Transient means changing, not always permanent. You see, I know this word because what did they used to call homeless people? They didn't set up tents in your neighborhood. They would jump off the railroad car in your neighborhood, panhandle for a while, then catch the train out to another town. We call them hobos, but we also call them more specifically transients. Somebody who was in your neighborhood and then out of your neighborhood. Got it? Coming and going. That's a transient. So guess what a transient ischemic attack is? Oh, I can't feel anything in my arm. By the time you get to the hospital, I can feel everything. So it came and went. Does that make sense? It was a blood clot or something that moved on. It didn't cause permanent symptoms. 10-4? Now, what about this word? Ischemic or ischemia deals with a problem with a blood vessel. I can't get the blood from point A to point B. Something's wrong with my vessel. Got it? Usually a blockage. Now, is a TIA still a problem? Yes, because if you have one of them, you might have another one next week. And maybe another one next month. And that one might be the one that's more permanent. So if you start having these TIAs, yes, it's important to check to make sure there's not something wrong with your blood or your heart. What is the number one cause of TIAs and blood clots? It has to do with your heart. Atrial fibrillation. Ever heard of AFib? Now remember, your heart is made up of 4 chambers. 2 atria and 2 ventricles. Got it? What should your heart be doing? Love, dub. Right? Squeeze, squeeze. Love, dub. That's why you have 2 sounds. Only got 2 motions. What's fibrillation? Instead of your atria going like this, it does this. It fibrillates. 10-4? And when it fibrillates, it's not deadly because all your atria does is send the blood down to your ventricles. Your ventricles squeeze and send it out to your body. Does that make sense? So when your atria are fibrillating like this, the problem is your blood, instead of flowing straight down to your ventricles, goes round and around and around. And when your blood goes round and around, platelets rub against each other and might stick. And when platelets stick together, that's called a clot. Got it? So a person with AFib needs to be on medicine to keep from throwing clots. 10-4? Now, what if your ventricles, instead of squeezing like they're supposed to, go like this. If they fibrillate, what's the problem here? Now I can't send the blood out to my brain and my body to stay alive. Is that a little bit more dangerous than clots? Yeah. And when your heart starts doing this, we say, clear, ka-ching, and defibrillate them with a defibrillator to undo this. You shock when the ventricles are fibrillating. 10-4? Now, if this person is constantly having this, we put a pacemaker in that will shock the heart whenever the machine in here detects that the ventricles are fibrillating. Does that make sense? As an implantable defibrillator. Does that make sense? Look, I'm giving you previews for 211. All right? All right. So, are there some degenerative brain diseases? Yes, we've talked about Alzheimer's. Okay, Parkinson's and Huntington's disease. Parkinson's, we have a problem with making our arms and legs move. With Huntington's, it's almost like the opposite. Your arms and legs move too much. That's why Huntington's is known as Huntington's chorea. Now, why chorea? Because it comes from the word choreography. What's choreography? Dancing. Because the first person to be diagnosed by Dr. Huntington, he wrote in his notes, they came in like they were dancing because their arms and legs were exaggeratedly moving. That's Huntington's. Okay? And it's a problem with nuclei. Groups of ganglia in your brain. It's called nuclei, groups of somas. All right? Alrighty. Hey, what were the 3 steps for making all the neurons in your body? What were the 3 steps for making all the neurons in your body? Okay, proliferation. What do we have to do? Make them all. What's number 2? Migration. Put them where they belong. Well, look, we put the blue ones here. We put the green ones here. We put the red ones here in the spinal cord. And what is the 3rd step?
Specialization.
Differentiation, where we make them become, this is going to be my sensories. That's going to be my motors. That's going to be my interneurons. See how that works? They're showing you right here. This is how it grows in your primitive spinal cord as you are forming in the uterus. Make sense? Okay. All right, spinal cord. What do we need to know? Well, spinal cord is all wrapped up tight with connective tissue until we get down here to the lumbar region. Here, it ends in a cone, conus medullaris, a cone in the medulla, in the middle. Got it? And then all the nerves past that are not covered in connective tissues. Here, this is covered by arachnoid mater, pia mater, and dura mater, but not down here. Got it? They're hanging as individual nerve axons. 10-4? And it reminded somebody of a horse's tail, so they gave it the name horse's tail. Or equina, tail, a horse, and cauda, tail. Tail of the horse. Everybody with me? Okay. Now, to keep those from being everywhere, this is anchored. Now, it's drawn in green on this thing, and I think on my lab practical, I'll have it as green also. There is a ligament that holds the conus medullaris straight down to the bottom of your sacrum. and that is called the filum terminale, or the terminal filament. Got it? The green line. Is it really green in your body? No, it's white like everything else, but we're just going to call it that. Does that make sense? And here's your plastic model. See the cone here? See the cauda equina? And if I simply painted this one green, that's your filum terminale. Yes, no, maybe? Okay. Alrighty. We got that. Cauda equina, spinal nerves. Remember we talked about there's one more nerve than there are vertebra, because we count number one above the atlas. Okay. Alrighty. Now, what does our spinal cord look like? This picture will be on your test. Put a big star by it so that you know that's an important thing. Alrighty? If you look at your spinal cord, and I'll pass around some of these models. Okay. From the back, you guys here in the front. Okay? We'll use this one together, okay? All right. When you're looking at your spinal cord like this, what's this part? Dorsal or ventral? Dorsal, because this is you leaning forward. Got it? So that's the back and that's the front. How can we tell this is the back? See that bulge here? Dorsal root ganglia. And what is always on the dorsal or the back side of your brain and spinal cord? Sensory. And the sensories have their bodies off to the side. Got it? There is no ventral root ganglia. Only the dorsal root. Make sense? Because only the dorsal is 100% sensory. What's the ventral root? 100% motor. Like your brain. The front is motor, the back is sensory. Your spinal cord is the same thing. Front is motor, back is sensory. Okay? All right. See? Gray matter, white matter. What's the white matter? Superhighways of myelinated axons. Got it? Up and down. What are the ones in the back? Superhighways of what?
Sensory.
Sensory. What is the front?
Motor.
Superhighways of motor. And guess what the sides are? A mixture of both. Didn't remember that? Mm-hmm. Some say merry money, other, my brother says, right? Mm-hmm. Aren't some of these groups all motor or all sensory or a combination of both? So is your spinal cord. Okay? Sensory, motor, both. Yeah? Okay, don't make it any harder than that. Okay, now here's the thing. We give these axons another name. It's called a funiculus. Funiculus. And we have a dorsal, two dorsal funiculi, two ventral, two lateral, and then two ventral. Does that make sense? Don't make it any harder than that. All right? Okay. Do you see 3 connective tissue layers? What's the one covering everything? What mater? Dura, like your skull. Underneath that, arachnoid, with the blood vessels looking like a spider web. And then underneath the blood vessels and directly touching is the pia. Does that make sense? Okay. You have a central canal that all the cerebrospinal fluid goes down, then it comes up underneath. Got it? Under the dura. Comes back up. Got it? To go around the outside of your brain so your brain floats. Yeah, basically your spinal cord floats too. Okay? Alright. Everybody with me? Alright. What's the next thing we need to know? Is that your gray matter has a part up here called the dorsal horn. This part sticking out is the lateral horn, and this part sticking out is the ventral horn. Don't make it any harder than that. Take a look here. What do we call these two horns up here?
Dorsal.
Dorsal. These two horns down here, ventral, and these two sticking off on the sides, lateral. What do you think? Got it? Okay. So you guys see all these, got those models in front of you, right? Okay. Dorsal root ganglia. No ventral root ganglia. These are sensories coming in. These are motors going out. Got it? Comes in. Interneurons, all this gray matter, folks. That's the interneuron sending the message on to the motor. Okay? All right. What's this? Where your dorsal and ventral roots come together, it's called a spinal nerve. So what's a spinal nerve? A combination of motor and sensory. Yeah. And that's what this is. These are the spinal nerves that are coming out of your spine. See it? On either side. It's a combination of motor and sensory. Going through that little hole. What's that little hole between the vertebra? Intervertebral.
Disc.
Disc is this flat thing. What's the hole? Foramen. Does that make sense? Intervertebral disc, intervertebral foramen. Okay. So, how are we doing? Hanging in there? All right. There you go. I always try to have your plastic model right. Incoming dorsal, outgoing ventral, spinal nerve, dorsal root ganglion, that bulge. Alrighty? Interneuron is here. Now, what do I call nerves that go from left to right and right to left?
Conlateral.
Commissures. Commissures. Now, what color is the commissure in your skull, in your brain? White. Remember? What's the name of that great commissure? That's going to be on your next lab practical. Corpus callosum, which we'll see when we dissect the brain next week. Okay? What do we call this one? Is it white?
It's gray.
So we call this the gray commissure. Because it's gray. It's unmodulated axons. Didn't we do the crossed extensor reflex? Or not? Well, it was in chapter, wasn't it in chapter 13? Okay, maybe it's in here, I don't know. All right. We got those horns. Yeah, see? Sensories are coming in, interneurons in here, and then the motor's going out. What do I need you to know? Not that it's going to be a definitely tough, hard, I'm going to give it to you test, but where's the body of the sensories? Where's the soma of the sensory neuron?
On the outside.
Here, in the ganglion. Where's the body of the interneurons? Here, in the dorsal horn. Where's the body of the motor neurons? Here, in the ventral horn, because that's their axons going out. Got it? So what is this? This is the visceral. So you have your somatic from your body sensories and your visceral sensories come in here. But this bulge off to the side is where your visceral motors start. And this is where your somatic motors start. Okay, that's all. We got the funiculi. Okay. Pathways, deconsate, don't worry about it. But look, what do I have mostly in this dorsal funiculus? Blue. Sensor. So are they going up or going down? Up. Ascending. What do I have mostly here? descending. The motor's going down. And what do I have a combination of on the side? Yes or no? Got it? Okay. Now, I'm not going to ask you the same questions that I do in my 16-week test. All I'm going to ask you here is to identify, is the name of this track, up and down, is the name of this track a sensory or a motor? And all you have to do is look at the name of the track. Origin and insertion. Where does it start and where does it go? Are you with me? Just like our tendons and our ligaments and our muscles. Some of them have a very simple name. Starts here and goes there. Where does this one start?
Spine.
Spine. Where does it go?
Thalamus.
Is that going up or going down?
Going up.
It's going up. If it's going up, it's got to be what?
Ascending.
Sensory. And the name is telling you. Got it? Spinocerebellar. Going up. From my spine up to my cerebellum. Because the name is telling you. Got to be sensory. Don't worry about that one. They gave it a name from something else. So he won't be on your test, except he's a wrong answer. All right? What about this one? Corticospinal. Where am I starting? My cerebral cortex. That's the big part of my brain. And then where's it going?
Spine.
Is that going up or going down?
Down.
So it must be motor. This one just happens to be on the side. Where's that one? In the front. Are you going to go, oh my God, I can't handle this? Because corticospinal tells you what it's doing. Got it? And again, this is an exercise, and either you can learn it the hard way or you can learn it the easy way. I prefer the easy way. If you know the parts of the word, it's going to be so much more helpful to you, even in nursing school when you have all sorts of drug interactions and things, you know? All right, how about this one? Rubrospinal. Well, you don't know this, but you have a red nucleus in your brain. Because what color is it?
White.
No, it's red.
Red.
That's what's called a red nucleus. Anybody? What color would the green nucleus be?
Green.
Okay, but there is no green nucleus. Okay. There is the red nucleus in your brain. And it's going to go from the rubro. What color is a ruby?
Red.
That's what rubro means, red. Down to your spine. So is that motor or sensory? 100% motor. Because the name is telling you, I'm going from here to there. Okay? All right. And again, I was going to ask you who's crossing over, who's not. Not for you guys. Don't worry about that. Okay? But I have put these that are sensory in blue and my motor is in red because that's the way we've been drawing it. Okay. How about some problems? You think you might need to know something about problems when you're going into the healthcare field? Sure. You're very lucky if all you see is healthy people all day long. Okay? Paralysis. You've lost function. Alrighty? Well, you got two kinds. Flaccid paralysis. What does that mean? Flaccid paralysis means move your arm. Move your arm. I can't. It's flaccid. I can't move it at all. Alrighty? This is severe damage to the ventral root or the anterior horn cells. Damage to where? The root down here or these cells here in the horn. Got it? So it's motor. I can't function the motor. 10-4? That's why I pick my arm up and it falls back down. 10-4? Okay. No voluntary, no involuntary control. Because starting in your spinal cord, no messages are going down to your muscles. However, some people in a wheelchair might have spastic paralysis. What does that mean? The damage is here or here from a stroke, but the nerves going to your arm and from your arm to your spinal cord are still working. So that's a person sitting in the wheelchair and their arm just kick out, or their leg will kick out. Got it? That's not flaccid. That's spastic. You're just like, oh, you quit acting like a spaz. You're all over the place. Got it? Sort of the Jim Carrey type of humor. I don't know, who's Jim Carrey? All right, I know he's already an old man. I knew him when he was in movies. But he always played a very spastic, goofy character, right? Okay. I don't know, who's spastic now for you young people? Like all over the place.
The guy who plays Deadpool.
Who?
Ryan Reynolds.
Ryan Reynolds? Okay, yeah, he's pretty spastic. As Deadpool, yeah. Okay. Wasn't there some idiot guy who, like Jackass, who did all sorts of stupid stuff?
Yeah.
He's pretty spastic, I think, isn't he? Yeah.
I can't remember his name.
Now you see, this really dates me. Back in the black and white days, there was a comedy team called Jerry Lewis and Dean Martin. Dean Martin was the straight man who always sang the songs, and Jerry Lewis was the spastic guy running around the stage going, oh, hey lady, what's wrong with you? He was very spastic. That was his shtick. Are you with me? So, involuntary movement, but no voluntary movement. Got it? Because the actual neurons going to and from the arm or the leg are still intact. Okay, how about a problem? Like somebody cut through or damaged your spinal cord. That's a transection. 10-4. If we have a transection between T1 and L, in other words, anywhere along your back, what's going to be paralyzed? Just your legs. So we call that a what plegic? Para. If you're transected in the cervical region, now what are you? Quadra, because all four can't move. Does that make sense? That's why a broken neck is the worst, right? Okay, I'm going to date myself again. Date as in not go out to date, but when I lived. Who was the guy that played the first Superman in the movies? Christopher Reeves. Well, one day he was out horseback riding. The horse kicked up. He fell down, broke his neck, and for the rest of his life he was in a wheelchair because he broke his neck. Okay? So Mr. Superman was literally just a little skin and bones body sitting in a wheelchair because there were no nerves telling his muscles to do anything, so all his muscles atrophied. Okay? So it's very sad, but that's the way it was. Now, what about this? What is wrong with a patient who is a hemiplegic?
Half of the body?
Half the body. Which half? Left half or right half? Got it? Not top half, bottom half. Left half or right half. Now, how did that happen? A stroke.
Yes.
So if there's something wrong with the left side of my brain, what side of my body is not going to work?
The right side.
That's the right side. And the same thing here. Got it? Because we cross over. Where do we cross over?
The thalamus.
We just said it.
No.
Corpus callosum. That's the superhighway of commissures going left and right. Okay, now I've said it a couple of times. You think it's going to be on your test?
Yes.
Yes. Lab and chapter test. Be careful. All right. Ever heard of polio? Why do you think we want our kids to be immunized with the polio vaccine before they go to school? Because polio is a virus that attacks what? The ventral horn motor neurons. It destroys the motor neurons in your spinal cord. Okay? Who's the gentleman sitting in a chair here? That is Franklin Delano Roosevelt, one of our presidents, the only president ever to be in a wheelchair. But guess what? No one in America but the Secret Service, the news, that kept it secret, and his family knew he was in a wheelchair ever since he was in his 20s. Why? Because back when he was president, if there was something wrong with you, the world saw you as a weak president. Got it? So it was never divulged that FDR was in a wheelchair. Well, that was before a lot of TV. This is the 30s, folks. So the only time you might have seen FDR would be on a newsreel, which is the first 10 minutes in front of a movie in the movie theaters. Got it? And what would they do? They would already have him standing at the podium before they turned the cameras on. And he's talking about this and that and whatnot. Okay? And he had his legs in braces that were locked. Okay? And he's holding on to the podium. Well, what about when he made personal appearances? He would have his charge d'affaires, his right-hand man, on one side, his grown son on the other side, and they put his feet on top of their shoes. And when they took a step, it made him move. And he held on to them. And he walked up to this, and they talked. Okay? Now, the cameras were told, don't turn on till he's at the podium. So only people who might have been there saw him walk that awkward way. But nobody else knew it. Okay? Because what was going to happen during his time as president?
World War II.
Yeah, how about World War II? Got it? And if other countries saw, oh my gosh, America's got a guy in a wheelchair, America must be weak, hey, let's attack America. Are you with me? Okay, so. But he had paralysis only from here down. His arms could still work. What about these poor people? Look, that's their head, and they're inside this casket-like machine. There's the head. He's in the casket. Got it? This is called an iron lung. They were paralyzed from the neck down. Why are they in the iron lung? It's a machine that pushes on your diaphragm to help you breathe because your arms and legs don't move. Can you imagine being in that thing for the rest of your life? And we had warehouses full of people like this. Okay? So here are the nurses. They make their rounds. Okay? And since you can't move your neck, you have to look at a mirror to see the nurse's face. That's how you communicate. You could still talk, but you couldn't move anything from your neck down for the rest of your life. Do you want to know why Jonas Salk, when he invented the Salk vaccine against polio, he was, declared a hero for mankind? And then when he said, I don't want a single dime for this. I want the American government to make it and give it out to everybody for free. Are you with me? And not just America, then later on it was the world. We've almost completely eliminated polio. Because if everybody's vaccinated, then the polio vaccine can't grow inside you to be given to somebody else. Alrighty? Yeah. Imagine just row after row after row of these people basically in warehouses, gymnasiums and stuff, where they would just, and nurses just have to walk back and forth and here's something to drink, here's something to eat, and the machine did all the breathing for them. Okay? All right, here's another problem. ALS. Ever heard of ALS? It's also known as Lou Gehrig's disease because he's the most famous person to come down with it. This is a progressive destruction of, again, the motor horn, the ventral horn. Okay? Now you might see this word constantly, pyramid tract, pyramid tract. Didn't we draw a picture of a brain? And inside the red area, didn't I draw little triangle-shaped cells? Those are the pyramidal cells that are the main cells that tell your arms and legs to move. Got it? So what do we call these tracts that come down the front? These are called the pyramidal tracts. These are the main ventral tracts, the main, dorsal back here, ventral in the front. The main ones coming down the front of your spinal cord that are telling your arms and legs to move. Well, they get destroyed slowly. Loss of the ability to speak, swallow, breathe, and death within 5 years, and that's exactly what happened to Lou Gehrig. And he's famous for being one of the best New York Yankee players until all of a sudden he wasn't hitting the ball as hard. He wasn't throwing the ball as far. And the coach said, you might want to get checked out. This is not like you. And that's when he was diagnosed. And they said, you've only got 5 years left to live. So he made a very famous speech during his last game. And he says, I consider myself the luckiest man on earth because I got to do what I love, which is play baseball, but I have to say goodbye. And within 5 years, he was dead. Okay? So it's tough stuff. Other disorders. Rabies. Rabies, you get that from the saliva of a rabid animal. That's why your dogs and cats need to be what? Vaccinated against rabies, because who knows, they might run into another dog that has rabies, or a squirrel that has rabies, or a raccoon, that's running through your garbage. Your dog grabs it, it bites them, boom, now your dog's going to get rabies. Are you with me? And it will destroy your brain, and that's why they go cuckoo and start biting people and animals and stuff. Got it? Yeah, you don't want to mess. You see a raccoon, you shoo him away, he turns on you, you better run because he might have rabies, he's going to give it to you. Okay? And then this one, mad cow disease. Okay? No, they don't look like that. But have you ever heard of mad cow disease? It happened in England. Okay? In the 80s. In fact, because Mr. Triana was stationed in Germany during the 80s when he was in the Navy, he's not allowed to give blood because they are afraid that he might have been exposed to mad cow disease and therefore that might be in his body still. Alrighty? I think they kind of gotten over that now and that he can give blood now, but for many, many moons they said, no. You were there in Europe, we don't want it. What's mad cow disease? It's not a virus. It's called a prion. This is a piece of protein in an infected brain that if eaten by another animal will infect their brain, causing it to go cuckoo, lose the ability to move, and they fall down and they're salivating over each other. But they did know that when one cow in the herd had it, pretty soon the whole herd would have it. And since we didn't know what it was it a fungus? Was it a virus? Was it a bacteria? We didn't know. People were so scared that if one cow in the herd had it, the government said, kill every cow in the herd and burn their bodies. Okay? Thank goodness it happened in England because that's an island. Yeah? Well, what about people who wanted to go to Europe from England? Well, first it was a ban. You couldn't. Couldn't take a plane, couldn't take a ferry, across the English Channel. Couldn't do it. Later on, this is, okay, we think we know what it is, but we want to be precautious. So before you got on the plane, before you got on the ship, you had to walk down a runway which was a carpet soaked in Lysol. So the bottom of your shoes, maybe the Lysol would kill the prion, and you wouldn't carry it into the rest of Europe. Okay? Now, thank goodness we didn't have an outbreak in Texas, because that's where all the cows, all the beef for our steaks comes from. But there was a case of one guy somewhere up north, maybe Minnesota, I can't remember. One of his cows came down with mad cow, and all 30,000 of his cows had to be killed right then and there. Well, guess what? The one he had gotten from a farmer in Canada. And he said, well, can't you just kill that one? No, got to kill all of yours. Okay? Because they weren't sure what it was. Alrighty? Well, does anybody know where mad cow comes from? This is why it started in England.
It's
Yes.
because they would feed the cows actual cow meat.
Yes. I don't know why, but the feed and seed stores in England, when they delivered the feed to the farmer, said, "Hey, Farmer Brown, do you have any Farmer Mac Brown? Do you have any dead cows in the field? As a courtesy, we'll take care of the body for free." Well, that's my neighborly of you. Sure, I think there's a dead cow over there by that tree. I was going to get my pickup truck and move it, but if you want to take care of it, go for it. They bring that dead cow back to the feed and seed store and grind it up. Bones, hair, everything. Grind it up and mix it in with the feed that they would sell to another farmer. Their philosophy is, hey, it's just protein. Cows don't care what they're eating. Well, here's the thing, folks. Are cows cannibals? No. Do cows eat any kind of meat? No. It's against nature. Are you with me? And guess what happened? When an animal eats its own kind, these prions get created in their brain. Now, the English people should have known better, the farmers, the feed and seed stores, because a few decades earlier, there was an outbreak of mad sheep disease called scrapie, where the sheep would scrape themselves to death on a fence post. I guess because their brain felt something was crawling on them, so they just kept scraping, and they would bleed to death. Well, what did that come from? The same thing. They would grind up dead sheep, hair and all, and mix it in with the feed for the next set of sheep. And again, are sheep cannibals? Are sheep, meat eaters, carnivores? No. So they should have known better, because guess what? The same thing happens if people eat people. This happens among certain tribes in the Amazon where they, kill the other guy and eat him. It's called kuru. That's what they called it. It's called Creutzfeldt-Jacobs disease, based on the two researchers who discovered it. Yeah. There's a mad person disease, too, if you eat their brain. Okay? Especially if it's raw. Now, what did Hannibal Lecter do? He cooked the brains of his victims, and that's why he didn't get it. Because you cook the prions out of it. Right? But eating it raw is the problem. Cool beans? Okay. Cerebral palsy. During birth, if the umbilical cord gets wrapped around the neck and cut off oxygen to the baby's brain for a certain amount of time, there's permanent brain damage from lack of oxygen during birth. Got it? And that means poor control of voluntary muscles, crippling spasticity, speech and vision difficulty, sometimes mental retardation, and that's why they have service animals that carry their books for them to class. Because the poor kid is busy on crutches. He can't carry the books. Does that make sense? And these dogs are smart enough. They can pick up a pencil that fell down for the kid. Okay? And they come to the class. We had somebody like that at Sumter High School. Okay? Sweetest little girl in the world. Okay? With her dog. Okay? Anencephaly. What is A or AN in front of any word?
Not.
No brain in the head. It's hollow. Obviously, that's stillborn. That's not a birth. But born with no, or growing with no brain. Okay? Microcephaly. Small brain. That's what Barnum and Bailey Circus, that's what they did with people like that. And then spina bifida. Instead of your vertebra closing like this around your spinal cord, it stays open, it stays bifid, and the spinal cord comes out. Is that healthy for the baby? If that spinal cord breaks, you're paralyzed. Okay? So, it's called myelomeningeocele, meaning your meninges are bulging out because there's no spine to keep it in place, and there's no vertebra to keep it in place. What is a good thing, moms, to be that the doctor will tell you take this every day.
The native vitamin.
Which vitamin? Folic acid, folacin. Folic acid is against spina bifida in your babies. Ever heard of Zika virus? That was a big problem in Brazil a couple of years ago, and coming to America, because people move. And the Zika virus that you get through the Aedes aegypti mosquito would cause microcephaly. Got it? The baby is all face and no brain. Microbrain. Okay? Because that virus would cross the placenta and go into and attack the baby's brain if the mama was pregnant. Very, very scary stuff. Thank goodness we don't have any Zika virus here. You can only transmit a disease through a vector like a mosquito if people already have it. Got it? Then it goes from you to me. Got it? But if nobody has it, there's nothing for the mosquito to bring to me. That's why we don't have, malaria here. Because malaria isn't endemic here. Does that make sense? All right. Shingles. Did we talk about that a little bit? Yeah. So, shingles, childhood chickenpox, can pop out because it hides inside your sensory somas. All right? Boom. Any questions about chapter 14, my friends? All right. Cut that.